Assalamualaikum. We from group 7. Today we're gonna present project math. Okay, my name is Muhammad Iqmal bin Ismail. I'm gonna present question 1A. Okay, so the question is, if a ball is thrown vertically upward with a velocity of 90 feet per second, then its height after t second is 90t plus 18t square 2. So the question A is, what is the maximum height reached by the ball? So the maximum height reached by the ball can be determined by finding the vertex of the quadratic function representing its height. In this case, the height function is given as ht equal to 90t plus 18t square. To find the maximum height, we can use the formula for the x coordinate of the vertex, which is given by negative b divided 2a, where a and b are the coefficient of the quadratic function. In this case, a equals 18 and b equal to 90. Using the formula we have, t equal negative b per 2a, so we put the number t equal to negative 90 divide 2 times 18. So the answer is negative 2.5. Since time cannot be negative in the context, we discard the negative value and consider t equal to 0.5 seconds as the time at which the ball reached its maximum height. Substituting this value back into the height function, we can find the maximum height, which is h times 2.5 equal 90, 2.5 plus 18 times 2.5 square. So the answer is 337.5 feet. Therefore, the maximum height reached by the ball is 337.5 feet. Okay, next.
Okay, thank you, Mama Iqmal, for question number 1A. So I'm going to continue the presentation for question 1B. So the question is, what is the velocity of the ball when it is 102 above the ground on its way up? So to determine the velocity of the ball when it is 102 feet above the ground on its way up, we can use the kinematic equation. So as we all know, the equation is v to the power of 2 is equal to u to the power of 2 plus 2as, where v is final velocity, u is initial velocity, a is acceleration. In this case, acceleration due to gravity, which is approximately negative 32.2 feet per second, and displacement is s, change in height. So based on so we have the information to insert all the values into the equation, which is u is equal to 90 feet per second. For the initial velocity, s is equal to 102 feet. Displacement, a is equal to negative 32.2 feet per second. So we need to find the final velocity, which is v. So using the equation, we can rearrange it to solve the v. So we just insert all the information that we have into the equation, and then the final answer is 1531.6 feet per second. So because we need only v, so we square root the answer before. So and the final answer is 59.1 feet per second. So therefore, the velocity of the ball when it is 102 feet above the ground on its way up is approximately 39.1 feet per second. So I think that's it for me. I will pass to the next presenter. Thank you.
Moving to our next question, which is C. What is the velocity of the ball when it is 102 feet above the ground on its way down? So, first of all, we need to find the time it takes for the ball to reach its maximum height. We can use the equation V equals to U plus AT, which is, we already have V final velocity, U initial velocity 19 feet, A acceleration negative 32, T time. We rearrange the equation. We have T equals V minus U, all of that over A. Then we substitute the value, calculate it, and we will get 2.8125 seconds approximately. Now to find the velocity of the ball when it is 102 feet above the ground and on its way down, we need to consider the time it takes for the ball to fall from its maximum height to a height of 102 feet using the equation S equals ut plus 1 over 2 at squared, where S displacement, U initial velocity, A acceleration due to gravity, which is approximately negative 22 feet per second squared, and time. Rearrange the equation we have and we substitute the value t squared negative 2u over a in bracket t squared minus in bracket 2u over 2u over a, then times with t minus 2s over a equals to 0. Then we substitute the value. After substitute the value, we simplify further. So we have t squared plus 6.375 t squared plus 6.375t plus 6.375 equals to 0. Using the quadratic formula, we can solve for t. So by using the formula, which is negative b plus minus square root b squared minus 4ac, all of that divided by 2 over a. So we substitute the value in the equation and then we calculate it. So we have two value, which is t equals negative 0.375 seconds and t equals negative 6. Since time cannot be negative, we discharge the negative value and consider t equals negative 6 seconds as the time it takes for the ball to reach a height of 102 feet on its way down. Now to find the velocity at this height, we can use the equation v equals u plus at, where v final velocity, u initial velocity, a acceleration due to gravity, t time, v. So so after that, when we have all of that value, we substitute in the formula and then we calculate. So we will get 192 feet per second. Therefore, the velocity of the ball when it is 102 feet above the ground on its way down is approximately 192 feet per second. That's all from my question. Moving to next question.
Go to question 2.
Okay, next is question 2. We move to question 2. Okay, question 2. If a tank holds 5,000 gallons of water, which drain from the bottom of the tank is 40 minutes, then torrencially loss give the volume of water remaining in the tank after a minute as V equal to 5,000 times 1 minus T over 40 square. So question A, find the rate of which water is draining from the tank after 10 minutes. First of all, we need to find the volume when 10 reach after 10 minutes. We just substitute T equal to 10 in using Torres-Lee law. So we can get from the volume after 10 minutes is 4,687.5 gallons. After that, we need to find the rate of which water is draining. We need to calculate the difference in volume between 10 minutes and 0 minutes, which means when the tank was full. So rate of drainage is V volume over time. Difference of volume in 0 minute minus volume after 10 minutes minus 10 over 10 minus 0. So from the equation, we can get the rate of drainage is 31.25 gallon per minute. Therefore, the rate at which water is draining from the tank after 10 minutes is 31.25 gallon per minute. Move to question B.
Okay, for question 2B, the question is determine the time of which the water is flowing out the fastest. We need to find the maximum volume of the expression given by Torricelli law. Equal the Torricelli law is Vt equals 5,000 multiplied by 1 minus T over 40 square, where Vt represents the volume of water remaining in the tank after T minutes. To find the maximum value, we can take the derivative of Vt with respect to T and set it equal to 0. So the calculation is dV T over dt equal to 5,000 multiplied by 2 multiplied by 1 minus T over 40 multiplied by negative 1 over 40. So we will get 5,000 multiplied by 2 multiplied by 1 negative 1 tolak 1 minus T over 40 multiplied by negative 1 over 40 equals 0. So we simplify the equation, which is 1 minus T over 40 equals 0. So the solving equation is T over 40 equal 1. So T over T equal to 40. Therefore, the water is flowing out the fastest at 40 minutes. So we continue to question C.
Okay. Test. Next, we move to question 2C. To determine the time at which the water is flowing out the slowest, we need to find the minimum volume of expression given by Torricelli law. V T equal to 5,000 times 1 minus T over 40 square. where t represent time in minutes. To find the minimum value, we can take the derivative of Vt with respect to t and set it equal to 0. dVt per over dt equal 0. Let's differentiate Vt with respect to t. dVt over dt equal 5000 times 2 times 1 minus t over 40 times minus 1 negative 1 over 40, simplifying the expression dVt over dt equal to negative 5000 over 20 minus times 1 negative t over 40. Setting the derivative equal to 0, negative 5000 over 20 times 1 negative t over 40 equal to 0. Simplifying further, 1 negative t over 40 equal to 0, and then t over 40 equal to 1, and the answer is t equal to 40. Therefore, the water is flowing out the slowest at 40 minutes. That's all for me.
Okay, that's all from us. Thank you.
Thank you.